My name is Reggie Edgerton. I'm one of the co-founders of SpineX. As a child, I was really interested in sports, and I think that's why I was interested in movement. And I got involved in swimming. The swimming coach was very scientific in biomechanics, so that was my first experience and beginning of excitement in science. Another scientist I met, he had kind of a philosophy, is that when you're working in a scientific area, you let the science tell you what to do next. You just follow the science. And that's what I did. A significant graduate student came to my lab and was interested in working in this area, and that was Parag Gad. Parag stepped in and took the initiative to start the company, and I knew we had to go in that direction. The way we got to the bladder and got connected with Evgeny, our other co-founder, right after our first experiment, NIH experiment, where we used an implant and referred to as an epidural implant, we thought that it was close enough to test our hypothesis that we could stimulate the spinal cord and maybe facilitate locomotion. In our first subject, not only did they regain voluntary control, soon after that, NIH wrote an article about bladder and bowel and sexual function because our first subject had shown those changes. So this was a new concept. And the fact that these multiple organ systems were responding, a lot of people thought that was important then, and more people are realizing is extremely important. The technology that we were using, we would use it to increase the excitability, or you might say the plasticity of the networks. Now, this is kind of a new idea. We're changing the mode of the spinal circuitry. The initial stimulation helps that to happen, and then if you start to train, the networks that are activated are the ones that become stronger. So theoretically, what we're working on is the idea that you have to go through the training process in conjunction with the neuromodulation of the networks. We were thinking just, how are we going to regain voluntary control in a sensory motor system? That's one of the reasons we're pretty confident that bladder was a good shot. It's basically retraining the networks so that the person can control when they would void the urine from their bladder. For example, a common problem with bladder function, particularly with aging and post-surgery and so forth, is you lose some of that function and you can't control when you release the urine. But it's very responsive to our stimulation. We are also very excited about the potential of the product with respect to cerebral palsy. And it is striking how many similarities there are cerebral palsy and spinal cord injury. For example, hardly anyone recognizes that a child with cerebral palsy has multiple organ dysfunctions. Most people think that it's a problem with walking, how they walk. But they have bladder, they have bowel, they have cardiovascular function, they have all of these things very similar to what happens in some spinal cord injury. They're always not the same in every subject. In fact, every subject is unique. The other exciting thing about cerebral palsy is the system is much more plastic when you're young. And so if we can demonstrate the effectiveness of this neuromodulation in a young kid and can get it done as early as possible, we're more likely going to have a greater effect. And the effects that we're seeing are pretty dramatic. There's evidence that the stimulation can help virtually every sensory system in the brain and the spinal cord. And this goes back to the other advantage that SpineX has in terms of the technology that's non-invasive. We can stimulate, we can move the electrodes whenever we want to different parts of the spinal column to treat different organ systems. Those are real advantages of the non-invasive technology of neuromodulation. Our simplified view of this pathway does this and this pathway does this has been so prohibitive in our thinking of creativity, in any creativity way. I think we're not even close to how the integrated organism functions. If we can learn how to change the connectivity to get a certain outcome, that would be pretty amazing. If we can manage all the potential that's in front of us, I think the company will expand its impact. We're using the best ideas available in biology and with the technologies that we have. So the critical factor is being able to be knowledgeable about the two and how they fit together. And with that, I think we have a great advantage in being able to apply these ideas to multiple organ systems. We've been thinking about this for about 55 years. And we've gotten to this point. It's built on science. It was not built on guesses.